In our final video for section 2.3 on first order linear differential equations, we're going to do one problem on modeling. So in this particular question, we're going to say that a cup of coffee has a temperature of 100 degrees Fahrenheit, and it is put in a room that is 50 degrees Fahrenheit. What is the temperature of the coffee after 1 hour? Well, if we let x of t be the temperature of the coffee after t hours, then by Newton's law of cooling, we have this equation dx dt is equal to negative of the quantity x minus 50. And we have that initial condition that the coffee started out at 100 degrees Fahrenheit. So x of 0 is 100. So this just gives us a linear first order ordinary differential equation that we must solve. And really, we are solving an initial value problem of that type. So again, we just want to find the equation x of t. Once we find the equation x of t, we evaluate that equation at 1, because we're trying to find out what the temperature of the coffee is after 1 hour. So we find x of 1, and that will be our solution. So, well, how do we do that? We go through and we write our equation in standard form. So first I want to distribute the negative. Then we're going to write this equation in standard form. So we get dx dt plus x is equal to 50. Here we notice that p of t is 1, right? That's the function in front of the x. And our integrating factor is always mu of t equal to e raised to the integral of p of t dt, which is e raised to the integral of 1 dt. So this is e to the t. So that is our integrating factor. So we want to take our equation in standard form, and we multiply that by e to the t everywhere. So let's go ahead and do that. When we do that, the left-hand side becomes the derivative of this product, which is our integrating factor times x. And the right-hand side was 50, but we got to multiply that by our integrating factor. So this is 50 e to the t. Now we integrate both sides. When we integrate both sides, we get e to the t times x on the left, and the right-hand side is just 50 e to the t plus c, plus some constant c when we integrate that. So then we solve for x. So this is x is equal to 50 e to the t over e to the t, that's just 50, plus c over e to the t. Okay, so we have x is equal to 50 plus c e to the t, and that is our equation to start with. That's our general solution to the equation. We do have an initial value problem here, though, which is x of 0 is 100. So let's go ahead and work that out over here. X of 0 is 100, so x is 100, and this is equal to 50 plus c times e raised to the 0th power, because t is 0 there. So e to the 0th is 1, so this says 100 is equal to 50 plus c, or in other words, c is equal to 50, which gives us x is equal to 50 plus 50 divided by e to the t. And this is the solution to the initial value problem. X is equal to 50 plus 50 over e to the t. All right. Well, we're not quite done, because really we wanted to know what is the temperature of the coffee after 1 hour. Well, again, we had x is equal to 50 plus 50 over e to the t. We want to know what the temperature is after 1 hour. That means find x of 1. And so that's 50 over 50 50 plus 50 divided by e. Now, that is approximately 68, and our units was degree Fahrenheit. Okay, and that is it. We have finished out this problem, and that actually will end our videos for section 2.3 for right now.